Guys, today we're going to take a look at implicit differentiation, which is just a very specific way of taking derivatives. So just kind of starting off, I guess. The graph of the equation x cubed plus y cubed minus xy equals 0. Initially, with everything that we have learned so far, we would not be able to take the derivative of that function. So there's just too much going on, and we have both variables on the same side, and we have that x, y, so those are kind of attached. So one way that we can use derivatives to solve this or to find information about a function that looks like this is by using implicit differentiation. Okay, so implicit differentiation again is used when we have variables that are like together, like when you have x and y on the same side, or they're being multiplied, or they're just like kind of combined, we're using implicit differentiation. Okay, so kind of diving right into it, we want to find dy dx if y squared is equal to x. Okay, so even a problem like this, we can use differentiation in order to solve. So to find dy dx, we simply differentiate both sides of the equation with respect to x. Okay, that's what that dy dx is saying. We're taking the derivative of y with respect to x. So treating y as a differentiable function of x, and then applying the chain rule. So what we are doing here is we're going to say when we take a derivative of something, especially with differentiation or implicit differentiation, we're taking a derivative with respect to x. So when I take the derivative of y squared, that's going to end up being, we know that that is 2y, but they say we're going to use the chain rule. So I'm thinking of this as y squared, and then I'm using the power rule. So that's the 2. And then that inside part is my y, so that's going to be times dy dx. Okay, so we're going to have 2y dy dx is equal to the derivative of, so just x is going to be 1. Okay, so now if we want to take this derivative, or if we want to figure out what dy dx is equal to, then we just have to have dy dx all by itself. So a lot of this lesson is going to be solving for things like this, and then we'll have to get dy dx by itself. So for this problem, dy dx is equal to 1 over 2y. Okay, and again, just to kind of walk you through that again, we thought of y squared as a function within a function. So we have 2y and then times the derivative of y, which we're just calling dy dx because it's with respect to x, and then is equal to the derivative of x, which is 1, and then we're getting dy dx by itself.